This is an AS Maths question on differentiation from first principles. Okay, so in this question we need to prove from first principles that the derivative of x cubed is 3x squared. So the first thing I'm going to do is just to write down the formula that we use when we want to differentiate something from first principles. So f dash of x, that's going to be the derivative, is the limit as h tends to 0 of f of x plus h minus f of x over h. And when you do this type of question, just be careful of your algebra as you work the way through. Make sure that at least once you write down the limit as h tends to 0. I tend to do it right at the start and right at the end. You don't need to write it at every step. And make sure that you don't cancel down the h too early. Otherwise you'll end up with dividing by 0, and we don't want that. So the first thing is going to be, I'm going to write down to let f of x equal to x cubed, the thing that I want to differentiate. So I can then write down that f dash of x, the derivative, is equal to the limit as h tends to 0. So I'm going to write it down here. That will only appear again right at the end, is f of x plus h. Right, okay, so that means just replace this x, or the x that you have in the function, with x plus h. So this is going to be x plus h cubed, f of x plus h. So x plus h, there's my substitution for x cubed, minus f of x, well that's just x cubed, over h. Right, I need to expand these brackets. To do that, I'm going to use Pascal's triangle, probably the quickest way to do it. So I get the coefficients 1, 3, 3, 1. I know that I'm going to start with x cubed and it's going to go down, and then the h is going to start from h to the power 0 and go up to h cubed. So we're just using patterns to do that. So I will have x cubed as the first term plus 3x squared h. So the h appears, the x goes down by 1 power, got a coefficient of 3. Next one also has a coefficient of 3, x to the power 1, h squared. And then the last term has a coefficient of 1, the x has gone, and now we're up to h cubed, and then we're minus the x cubed. Now I'm going to put this in brackets. I don't need to, just in case if I've got any negatives that I need to be careful about, like that. Okay, so expand the brackets in the first step, and then that's all going to be over h. Right, next step, let's simplify, tidy up what we've got at the top. So the x cubed and the negative x cubed, they're going to cancel out. And what I'll have left is 3x squared h plus 3x h squared plus h cubed over h. What I want to do from this step, I want to cancel down the h, because I don't want to be finding the limit as h tends to 0 with h at the bottom there. So let's cancel down the h. So I know that these will cancel out. This power will become 1, and this power will go down to squared. So let's write out what we have. So 3x squared plus 3xh plus h squared. So now I'm going to write out this limit as h tends to 0, and the limit as h tends to 0 of 3x squared plus 3xh plus h squared is going to be equal to 3x squared, because all of these basically are going to become times by 0, so they're going to disappear. And we should always finish with a conclusion, so we can write down, therefore the derivative of x cubed is 3x x squared as required. You don't need the as required bit.